Hello, everybody. Thank you for joining us for our second webinar. We have some exciting guests today from Cogent America and Koalaa. Some of you might know these folks, but they'll dive into their entities, their products that they're showcasing and bringing to market to the US. But before we get started, I just wanted to spend a couple of minutes talking about calibration marketing. We offer product marketing, go-to-market strategies to smaller entities, to clinics, anybody really that doesn't have the capacity to bring on a full-fledged marketing team and just needs a little bit of strategic insight, some planning, somebody to execute, write content, things like that, because I've seen that there is a need for that, especially in the smaller clinics and smaller startups where there's no bandwidth to bring on a full-time person, but those things still need to get done. So if you have anything like that that you need help with, please don't hesitate to reach out. But with that, I will start with Nate Macabuag from Koalaa Prosthetics.
Hello.
Soft Prosthetics. So, hey, Nate.
What is up?
Oh, I'm glad you're here today. So tell everybody a little bit about yourself, about Koalaa, and then later on we'll dive into a little bit more of the product end of things and who you're really targeting with these products that many may not have seen in the US quite yet. But I've certainly been stalking you guys and seen all the great things that you're doing. So take it away.
Oh, thank you. And thanks for inviting me to this. This is really fun.
Oh, yeah.
So yes, I'm Nate Macabuag. I'm founder of a company called Koalaa. And in a nutshell, we make soft prosthetics. So we make prosthetic limbs and assisted devices, but we make them out of fabrics and we make them like clothes. So we make them like sneakers. As I said, they're soft, they're rigid where they need to be, but adjustable, flexible where they can be. And then the general principle is that instead of one sort of device on the end that does everything, we have just different specialized tools that clip in and do different things. So it's very much adaptive equipment. And it very much came from, in fact, I fell backwards into this a few years ago when I was at university. So I actually studied mechanical engineering, so I'm not a clinician. So I have the benefit of not knowing how things are normally done.
That's okay sometimes.
Sometimes it's helpful. And so I got introduced while I was at university to another designer, but who actually used prosthetic limbs, a guy called Alex Lewis, who's well worth a Google, a very cool guy. And basically we're talking to him and he broke down the problems that he faced and what he wanted us to work on pretty clearly. So he was a quadruple amputee. So both his legs, both his arms. And he's basically saying, like, look, guys, I wear these devices all day. Just make them really, really comfy. Just make them really, really easy to use. So I don't have to train. I can just pick them up and go and make them easy to get. So I don't necessarily need multiple fittings. I can get them in one fitting. I don't need to fundraise loads of money. They're affordable. And we just sort of listened to that. I was like, well, that makes a lot of sense. We can't have been the first person to invent this problem. There must be other things that we wear that are comfortable but also functional. And that's what down the idea of sportswear and clothes and shoes and what features there can we steal and put into a prosthetic limb. And that's what we've been doing ever since. And then we did it for Alex and we kept doing it. And then you look back and you're like, oh gosh, now it's a company and now we're doing stuff all over the world. And this year particularly, we're putting a lot of focus into the States and trying to learn and see how we can help over there. So
yeah, and you've had a lot of success with funding. There were some stories that just circulated recently about that, so that's super exciting. I'm sure that helps.
That helps. It's good. Yeah, that helps. I mean, it was also particularly nice because one of the funders of us was my old university.
Okay.
And I spent a decent amount on university fees, so that felt pretty good. So that felt quite nice.
Yeah.
Also, I mean, it's tough at the moment, and it's especially tough because we started purely because we made this first crappy prototype for Alex. Just university, made the first thing, gave it to him, and he was like, "Guys, I love this. Like, I would buy this if I could." And we were like, "Man, that's for students who know nothing shouldn't be able to do that. It's a nice feeling. We just want to keep being useful.
Right.
And that's sort of where we started. And so to find people to back us and essentially agree with our mission, just trying to be useful to people
Right.
around the world, it's like encouraging to find that. So it's
no,
nice.
and we'll talk more about all of it, but it is nice. I know you're heavily in the sports area. And those devices are often very hard to get for people. They're expensive. They don't always tie into other solutions. They're not always comfortable. So it's nice that there is that offering to look to, that users in the US will be able to explore and not be, not have to spend exorbitant amounts of money and worry about will insurance approve it or not. So, but we'll talk about that in a second. Next, we have Ted Varley. Some of you may know him. Those that do not now do. He's been around for quite a while with Be Bionic, developing that hand, Steeper, with the Covey hand. But Ted, I'll let you tell your story before we dive into everything that you're doing lately.
So hi, Linda. Thanks for organising this. Yeah, I had a slightly different approach to or introduction to prosthetics than Nate. Mine was more of a 15-year apprenticeship through the old guard of prosthetics. Actually, prior to prosthetics, I was in car design. So I used to design bits of interior car trim, and I went for a job thinking it was a car job, and it turned out to be Steeper, and they was just starting out. I didn't do much research, as you can tell. And they just were starting out on the Be Bionic journey, developing. So I joined the Be Bionic design team, and that was in 2009. And then went through all of those design iterations, all the sort of lessons learned of all the sort of multi-articulated hands, and generally establishing a specification of what customers and users would find useful, and what was physically possible. And then after that, the Be Bionic was sold to Otto Bock in 2017, and the team behind the Be Bionic was still keen to continue developing multi-articulated hands, and that's where Covey started. So 6 guys went into a room, and 2.5 years later,
came out with a hand.
Came out with a hand, and again trying to solve people's problems and really understand what would be beneficial. At the same time as that, because I'd never founded a company before, I thought I also founded Cogent, which did effectively manufacturing. So we manufacture actuators, motors, gearboxes for other healthcare applications such as stairlift, winches, and it was just really a bit of a side project at the time, and that has actually had grown into the full-time job, which is great now, because we've got a position where we have some kind of very high-end machines. We can make some very precise gears, which then we can manufacture into prosthetic hands. So
and it's interesting. It's a perfect segue into, now you're taking that to be also US based, right? With Cogent America. So obviously Cogent Mechatronic falls in under there, but you have these 2 other exciting things that we've been seeing a lot about, or a little bit about, depending on who you are. I know you were able to attend Hangar Live this year, 2024, with the MyoRocket. So there's obviously a lot of these technologies in prosthetics are a bit stale because the larger companies, obviously take a long time to come out with anything new due to a lot of internal things that have to happen. So it was exciting to see the MyoRocket. Everybody seemed to hang on to that. And then we've seen teasers, I guess you could say, of Rebel Bionics. So I think you mentioned, as you said, continuing to try to solve people's problems. But if you could talk a little bit to these two interesting entities and how they and where they fall in, and what made you want to make another hand.
So I think it's an itch that I'll never stop designing. It's just so after sort of leaving COVID, that was a very challenging sort of 4 years. We launched a product which was effectively two letters away from the virus that was ravaging, and we were just trying to
timing's everything.
It was really challenging. That was a very challenging.
I didn't think about that until just now.
And we literally went to, just as the virus went live, we were also trying to go live at the same time. It was very, very challenging. So I kind of, in 2021, reassessed things and ended up working just in Cogent with my brother, and then kind of started putting my feet back into the prosthetics. We started doing some research for the research arm of the NHS into children's prosthetics and people or children's access to prosthetics, and also the recyclability of prosthetics. So we did these two projects, and it was really interesting that not only it wasn't we found that kids weren't getting the opportunity, but people weren't, full stop. I met people who double amputee who'd been told by a clinician that he wouldn't be able to use a myoelectric, and within 5 minutes had him up and running. I've met people in the street, got chatting with them with a limb difference, and not really had the opportunity. So it was really then the idea started flowing, and it was like, how can we start like effectively allowing users to prove that they have the signals to be able to drive these hands. And then once that's proven, let's design some hands that are not just a very expensive initial purchase, but then can also, for children, can be effectively modified and grow with the child. So the idea was with Rebel is the core componentry stays with the user for the life of the product, but the hand can then be reconfigured as the child grows. So the less expensive parts, like the fingers, thumbs, and even like the palm chassis, we can bring those in, reconfigure the device, and send it back out effectively the same day, a larger size than it came in, with very minimal costs. And then for the NHS, we'd been looking at then how do we take those parts that have come off and then ensure the quality is correct, they're cleaned and can be then assessed properly to then go back onto someone else's. So things aren't being thrown away. It's all part of a cycle effectively.
Right.
So that's kind of where Rebel has come from. And at the moment we've done a children's sort of concept with some quite novel gearboxes in there, and then we've done a small adult version as well, which we're going to pull to market first because it proves out some of the technologies within the kids one, and then keep working on the kids hands in the background,
which is great because obviously there's not a whole heck of a lot of smaller hands out there for females, petite males, just smaller individuals as a whole.
What was quite interesting when you're launching trying to launch a project for kids is testing products on children. You're like, this isn't going to go down too well because we need to find things to be able to test on. And they was like, right, well, we'll make a small adult one and we'll test it on adults, but the eventual product would be for children. And then the people we had lined up for testing were like, well, actually, this would be quite good for me. That's kind of where that evolved from. And then the MyoRocket was just like a completely crazy idea. Nate and I were down in London doing some joint development work, and I got stuck on the train on the way home for 5 hours. And kind of one of the things that we've been discussing was like a tester, some sort of, and it started off as a Pokemon ball where you could plug it on to a socket and kind of effectively play a game to prove that you had the myo signals. And it very quickly, over about sort of 6 weeks or so, evolved into a rocket. So the idea is you've got a desktop device, the cables come away from it, and then they're held in one of Nate's, a short length of Nate's socket. So the electrodes are held in at the right position and clip onto the arm. And then from there, you've got an LED array for both open and close.
Okay.
And quite the clinician and the user can both see the device and whether it's working. You can also quite intuitively move the electrodes around. And it's almost like we had it with Sarah at Hang Alive, where she, congenital user, with not really, you're saying, do this with your wrist or do this with your wrist. Well, you haven't got a wrist, or you've never had a wrist. So it's very difficult to find those muscles. So she effectively just played the game and then self-diagnosed her own myo signals. And within 5 minutes, she was like, it's not open and close anymore. It's the red and blue. Yeah. And she was playing the game within 5 minutes. And
very cool.
Very, very, very cool. And the whole idea is it's a low-cost device that people can have on the desk and try it out. And gives you that, instead of having the expensive, 2 electrodes, wrist, full bionic hand system to prove whether this is the right solution for you, you can separate that and say, okay, you've got 2 strong signals, you've got no crosstalk. Now we can start talking about the most suitable device for you.
Well, and maybe that's also something that for those that are not congenital and post-op, it's something that you can train with, and a prosthetist or anybody that's involved with that patient can make some of those initial assessments as to what the options could be for an individual. And I did see somebody wave hello. So by all means, ask any ask any questions you have. We're going to try to answer as many as we can. And if not, we'll do so afterwards. But that was another fantastic segue to sharing a little bit about Koalaa. So, Nate, and I know some of what we've also talked about is that post-op scenario where Koalaa could be utilized for those individuals as well, and just starting to get used to wearing something. And it's perhaps even a gateway to figuring out, well, what is that right tool down the road? But initially, at least they have something and not just waiting around for months on end doing nothing.
Yeah, it's exactly that. And actually, I've got a few here.
Yeah.
I'll show you how the bits go together. And what I want to go back to what Ted just said, because it's so much of it is really interesting, and I think not necessarily immediately obvious. But basically, so this is like a full Koalaa sleeve. So we started with the below elbow version. We also do versions for partial hand.
Okay.
Runs for like little teeny tiny tots. So this is like a Koalaa.
Yeah.
Anyway, the basic makeup of it is, so you've got the end attachment, and then you have the sleeve. And then we have different fabric covers that essentially can be anything. These are literally fabric, and they reattach. And then you have the underlying, what we call the blank. Okay. So this part comes in like a full length, and essentially you pick between small, medium, large, like fitting a shoe, and you just cut it down to the length that you need. Then you chuck on the wrist, screw it in, and you're done. So the actual fitting process itself takes, honestly, minutes.
That's amazing. So it takes no time for the clinician to do this for the end user.
And someone can leave in the same appointment. So if they have a half an hour appointment, they can come, have an assessment, what tool is right for you, put the sleeve on, off you go.
Yeah.
I remember, so we were talking when, me and Ted were talking, and, Ted just gloss over that, but I can't explain how bafflingly quick he made this. It was ridiculous. So we spoke about it, and Ted was like, this actually, it'd be quite useful to be able to do myoelectric stuff in one session and be able to test and do that. And then we're talking like, you could clip something on the end, you could do this, you could do that. Oh yeah, I'm gonna CAD that. I've got a train journey later. I'm gonna CAD it later. And then a few days, Ted sends me like a picture of the rocket. I'm like,
of course, I would expect nothing less.
Yeah, I'm like, that's lovely. That's a really good render. How did you do that? It's like, it's not a render. I've made it. I was like, what? It's like, but all that to say, essentially, this is based on the idea of modularity, and trying to make that barrier to actually trying something as short as possible. I think it's an interesting thing about the MyoRocket in that so much of, from what we hear, and this is just what we hear from users, is so much of the barrier of trying a myoelectric device is that initial socket, that initial fitting.
100%.
Components.
And making sure it fits, because if it doesn't, off in the closet it goes.
Are the sensors in the right sites? All of these things. And then, especially, there's a big difference, as we all know, between being an amputee and having a congenital limb loss, like being born difference. And so Sarah, who works with us, has a congenital limb difference. And exactly saying those kind of things like, just move, tense that muscle, move your wrist down. It really doesn't have any meaning.
Right.
So being able to have a game is exactly what you did. I need to move the rocket down, and it moves down if I do this, and it gives that sort of feedback. And what we completely gloss over is the fact that, she came over, and probably about 45 seconds, a minute later, she had essentially the back end of our sleeve with TED sensors and game, and she was playing with it, and she was learning. And what she was actually doing was learning how to control a myoelectric device within a handful of minutes, and that's quite exciting. And I think that's what we're trying to do in the States with clinicians, is trying to see how can we essentially try and make life easier for the clinical team. What things take a lot of time? Is there any of the bits that we provide? Shorten that time so you can do stuff quicker, especially for people like kids who are relentlessly changing size. Speed is very important. Or for right after an amputation, where every single day you're essentially, if you don't have something to wear, you're learning to not use that limb. So these elements where speed is quite important. That's where our collaboration is really fun, because we're able to go in there and do stuff within minutes and start to see outcomes.
And comfort, and just making sure that they wear that device, so they can get, like you said, get used to that feeling and doing things with both hands. And so
it's really important as well. Again, as we probably know, but matching the activity, like really understanding what activity the person values. Because oftentimes, so for Alex, the first guy we worked with, he was a designer. The one thing he wanted to do, of all the million things, the one thing he was like, I want to hold a pen. I want to hold a pen so I could draw. That's all I want to do. And when you find that thing, then you can have the specific tools to do that. And so getting to that point as quickly as possible is really useful. It's why we have kits. So everything we make comes in sort of like these kits that you need to fit a person. So it's got, all the different sizes of sleeve. And then in the front, it's got all the different sort of attachments and tools that do different things. So someone can just try them out there and then.
Which is huge.
Essentially getting to where they can play with stuff as soon as possible.
And looking on your website, you've got kind of these three real avenues, if you will, and then this activity and customization that is over all of it. And like you said, partial hands, below elbow, and for those little ones. And then they can kind of go from there depending on what they want to do. And I know I've seen a lot of sports related activities that you guys are highlighting. Ashley, who some of us know, Ashley Sherman, she was in the Barbie movie, has worn a number of different prosthetic hands and is now so thrilled to be able to do cartwheels and handstands because she has this device. So it's heartwarming.
Well, it's great. It's amazing what you can do. So she came in a couple of weeks ago, and because you can chuck stuff on immediately, you can have live conversations with people. And people are like, what are you interested in? Oh, I'm interested about this. Okay, well, here, try that. Put it on. Here's some tools. Give it a go. You can do it there and then. And that means there's a world of difference to even coming in and then having to leave and come back a week or so later.
I'm sure.
Like a world of difference to people. And so that's what we're really focusing on. And we're finding that sports and activities like that, like hobbies, is an area where people often have one or two things that they you really want to focus on and like now. And that's sort of where we're starting. So,
no, and it's interesting because both of you guys are, kind of doing these innovative, rebellious, offering these innovative offerings. And again, things that I think anybody outside of this industry and anybody that finds themselves in this situation think, well, why isn't there something for me? Or, okay, there is, but why is it, $15, $20, $30, $40, $50,000? I just want to have something that fits me well so that I can use it every single day. And I've heard time and time again where somebody may get fit with something that they think they need, or they've been told that is the right solution for them, but the socket fit may not be right and they never wear the thing. Or at the end of the day, it's not really that thing that they need, the right device, or they need multiples. So the fact that you both are focusing on that audience that it hasn't necessarily been overlooked, but doesn't have a solution because it's hard to make one. And to you, Nate, it almost seems like, well, this seemed insanely easy. Why isn't anybody else doing this? And I've been in this world for eons, and not eons, but you've had your ups and downs, and what works and what doesn't work and what's necessary from having talked to all these people in the industry and users and clinicians and seen what other manufacturers are doing. And there still remains this gap.
I think it's quite interesting that I think it's just been a given, a known, is the socket construction. It's not really being questioned. And when the Maya placements is a bit of a black art, the fitting of a socket is a bit of a black art, and then we got together last year and spent a week just. I hope Nate won't mind me saying, I was skeptical of the stability and the fit that this was going to work, and I came back from that week in London just going, but this works. It really does. It's incredibly light. It's incredibly stable, and you not only pick, you just get to try so much so quickly that what's not right for you, what is right for you. It's very, very fast, and it's not a replacement for a traditional socket. It just it's another relatively low cost to be able to open much more avenues of activity. You got some of these limbs, once they've got the battery system in them, they've got a hand on the end of them. They are, you're getting up to 1 kilo. That's quite a lot, or 2 pounds. That is quite a lot of weight to have. And then that's quite a lot of weight to then thinking, I know what I'm going to be doing. I'm going to do some yoga, or I'm going to do this, I'm going to do that with that amount of weight. So I think it's definitely a comp.
Oh, we lost you for a second.
Oh, sorry.
No, you're back.
I was just saying it complements the offering. If you've got a limb using a traditional methods, then having one of the Koalaa limbs as well for specific activities is absolutely ace.
Well, I mean, as you know, so when I was in university, the hand that just came out was the hand that Ted designed. So
which one?
The little B by.
Oh, okay.
And so to hear that from the man himself is massive fangirl moment for me. So that's really nice to hear. But I mean, the thing that, to accent exactly what Ted has said, it's all about trying stuff as quickly as possible. And what I think is quite fun about what we're doing now, what we're trying to do together, is have an ecosystem of stuff, so that, because what we make is, Koalaa is currently, it's all the passive stuff. It's simple. It's, you know,
Sure.
what Ted's designed and built with the rocket, the MyoRocket, that modularly fits in this.
Mm-hmm.
It allows a person to continue that trying of new things and opens up a world of myoelectrics to a whole range of people that previously would not have been able to do that, and a whole range of, you know, clinical environments that wouldn't have been able to get the stuff to try it. So that's what's particularly exciting.
Mm-hmm.
And what, yeah, I'm looking forward to a lot.
I have a slew of questions. One of them is, what would you say for anybody that's listening that is from a startup situation and is entering this world of upper limb prosthetics? What has been one of the larger challenges with these projects for you guys over the time? Is it Ted, is it the size component and making sure that everything works? And I think that's why a lot of manufacturers don't have smaller hands. At least that's been my experience. Obviously, to go from larger to smaller, it's a challenge and things can break. So it's interesting that you're starting from the other side of things. And for you, Nate, I'm sure it's, trying to make sure that the socket doesn't slide off. And it's, these are my assumptions, but I'm curious from your point of view, what has kept you up? And I'm sure there's things that still keep you up and will continue to do so. But what was that like? Oh God, I'm so glad that we're over that one.
I'll jump in. So I think mine was just like a bit of a dawning realization that since the B-Bionic Small, there hasn't really been a very small hand that basically addresses most women's hands and then teenagers and children. So it's kind of then, and I was able to, with the freedom to be able to like start thinking about it without having the pressure of VCs or angel investors looking at it. I just, out of my own curiosity, just see, well, what is possible. The interesting things that there has been quite a lot of advances in sort of 3D printing, which does give you some benefits. One of the main challenges for particularly small hands is it's the cross-sectional area of the pivots. And although they'll fail under impact loading, they'll big chunky like 3D printed parts are incredibly strong. Once you take the wall section down to very similar size to the layer heights, then you end up being able to break them. So you really have to go with a metallic solution for especially fingers on a very small hand. There isn't any plastic that will withstand the impact. Yeah. But there is techniques that are coming out where you can, especially 3D printing can help you iterate more quickly, and you can test the hand in plastic and then make it finally in metal. So that's definitely, been a massive advantage. And also computing power is ridiculous now. So when I first started at MG Rover, my first career, there was a guy who had a CAD station and he came on a trolley once a week. And it was, and now I can design on a plane,
or on a train.
On a train. And it's just like that has definitely the accessibility of like the design tools is incredible. That's really accelerated the development. Advice to people getting into the segment is definitely try and fail fast. If you really, prove your ideas out and get as far as you can without external cash. It's my definite advice.
You know what? That's literally exactly what I was going to say, because there's obviously so many challenges, and Ted's the GOAT. Ted knows 10 times the amount I do. I've only been here a very little time. There's obviously loads of challenges. I think the high level, it doesn't keep me up, because I actually find it really fun, but there's so many assumptions that we come to with prosthetics from a place of never using them ever. So many assumptions we just inherently have that just need dispelling, like right out the bat. And it's exactly what Ted just said, like fail fast. And the easiest way to do it is you need to go and chat to the people who use these devices. First thing you need to do, go talk to them and be really honest. Don't come to them with ideas. Ask them what they need and what they want, because they'll give you the ideas and they'll show you where all the gaps are.
Yeah.
That's probably the highest order thing that I see, because I meet people from my old uni and other stuff that are just starting out. And they're going down avenues that I know, I'm like, you haven't spoken to anyone, have you? You need to go speak to them, because they'll. So it's that's the thing that I certainly as an engineer we struggle with. We love to tinker, and so that's the number one thing to get over, to be so super comfortable with having someone tell you your idea is wrong because you've learned from it. Just go talk to people.
Oh yeah, and obviously I don't come from an engineering mindset, but that's the first thing that these days makes me cringe, knowing that any great engineer can make anything great. Yeah. But if you haven't, like you both said, asked the questions, spoken to the users, gotten their feedback, and there will more than likely be most of the things are going to be unilateral, regardless of what part of the world you are in. But there will be very specific nuances to each different market. And if you haven't addressed those, you may as well not try. And it's such a small industry that if you don't do it right, you're going to fall flat on your face. And the clinicians that are doing this every single day are not going to waste their time giving you more chances if you haven't spent that time with them to make sure that they're being heard. And that's what always I see a lot of things on LinkedIn, on, everywhere. And it's just like, oh, I don't understand this messaging. Who is this really for? And what is this answering? And sometimes, like you said too, Nate, it's my assumptions. And then I have that conversation with those manufacturers or whoever it is, and they tell me, well, no, we have talked to people. We're not trying to build a bunch of superhumans. We're not trying to say that it's for everybody. And I feel a little bit better, because at least they have an understanding. But if you're just out there saying, this is the best thing, it'll solve your problems, it's like, no. None of these devices do. They all do in their own way, but they don't give you everything. There's no way. And so speaking to those unique markets, obviously I've seen some things, a number of folks I'm sure here that are listening in have seen you tapping into the US market. What are the plans? Are you intent on thinking about something this year, in the coming years? Obviously there's a lot of things that need to be considered from a PDAC and an insurance standpoint and things like that. Obviously, making sure that these devices are supported so that there's a US-based entity here, so that it's not just shipping stuff all over the world to support these users. But what are you thinking about? What can users expect? Can they reach out to you if they have questions? I know, Ted, for MyoRocket, I've seen that you guys are talking about some initial pre-orders, clinicians being interested in these types of devices. What are y'all thinking?
So, just from experience, it's a man who's had to stay up very late at night. It's almost impossible to support the US market from the UK. And I've done it too many years. You have to have boots on the ground in the US. So from we've set up a small subsidiary in Texas, and our plan is with big push to get the sort of the small hand up and running. That's going to go to OT World this summer, and then we're going to go to AAOP. So effectively, that'll then be our Halo product, and behind that we'll be supporting the MyoRocket and our charge points, electrodes, all of those sort of accessories as well at the same time. So that effectively local support, stock held in the US, and then specifically a lot of the designs we've done is I've not been frightened to throw things away and try and keep things as simple as possible and have it in the mindset of you know, if it's not doing about 3 different jobs, what else can it do? You know, can this be the cover and the chassis? So this is all with a mindset of, if it can be repaired, less components means less chance of failure, and then also less components is easier to fix. So we want to be able to repair this locally as well, and get it turned around quickly. But yeah, that's one thing I've learned over the years, is don't be frightened to throw things away. You know, from those feedback where people, I think a younger engineer and myself would like be more belligerent and try and defend what I was thinking. Now I'm just like, good point, well made. I'll throw that away and we'll start again, because it ends up being a much better product in the end. And to get to a finalized design, you need to have at least 10 in the bin of tried and stuff that you've thought this is it, and actually chuck it away.
Right. There you go.
I kind of love it. I mean, this is getting a bit design nerdy, but like I had a teacher for my high school called Mr. Ryan. That taught us like design technology and stuff. He's an amazing guy. We still go to dinner with him, like 15 years later.
Nice.
But he would always go on about fab design, FAB, Thunderbirds, its features and benefits.
Okay.
What's he saying? Like, look, Nate, every product has features that, you know, if you can't point to a feature and articulate very clearly what it does, what its benefit is, delete it, bin it, get rid of it. To the point where now I actually find it really satisfying. Like, I love feedback when someone's like, I don't need this or this or this. It's amazing. We can delete all these things. We don't have to worry about them, because every feature inevitably down the line, when you try and produce them in any kind of scale, will give you 5 problems per feature. So
I'm sure.
I could not agree more with deleting that. In terms of what we're doing in the States, it's just echoing Ted. So boots on the ground, so that we can support sort of customers quickly. And also put in a lot more face time. So in a nutshell, we want to be going around to clinics with kits and training on just what the bits do, and having the full range of stuff from, like, you know, really simple bits, including MyoRocket, all the way up. And doing that with clinicians, but also going to in-person charity events.
Yeah, Lucky Finn, Move United, maybe.
Yeah, Camp Limit. And essentially go and give clinicians and users as many opportunities to try before they buy. Because all of our stuff is on the web, and we're partnering with as many clinics as possible that want to stock it themselves.
Awesome.
So there's plenty of places for people to go and get them. We want to give people the opportunity to hold them, try them, put them on, play with them before they buy anything. So we're going to be doing lots of that, essentially.
I think
all great things.
Sorry,
go ahead.
All of those things are a two-way street, because it's like it's invaluable educating people on what products you do, but it also then turns into R&D for the future. So you kind of come into something going, actually, that is a great idea. The next batch, we can do this.
This is the thing. All of our products are named after people, because all the ideas come from someone. They've come from a conversation with a user. And you're absolutely right. Like every single device we give out, you get 3 or 4 ideas back. I go, have you thought about this? Thought about this? From users and from clinicians. So that's what we're going to be doing. Essentially, learning as much as we can, and just play with our stuff so that we can learn how to make it better.
Well, and it's great that you guys are also small and nimble, so that you can take all that feedback and immediately spit something out in a reasonable amount of time. So that people do feel heard.
We're quite impatient, like as a design team, and I get the sense the same with like we're quite impatient when we have an idea. We're like, let's do it now. Let's do it like right now, which is really fun.
Oh yeah, I believe it.
Move quickly.
No, so thank you for joining me. If there are any questions after, I'll put this up. This is where you can find all of us, our respective websites. So please, by all means, reach out if there's anything that anybody is curious about afterwards. I'm sure you can link in with any one of us on LinkedIn. and let us know how we can help. So thanks, guys.
Thank
Cool.
you.
No,
Thank you, Linda.
Have a good one.
Excellent. Thank you.
Bye.